Hi friends, we'll now keep on constructing the molecular orbital diagrams. Now here we will discuss the uh, second row elements. So we'll construct molecular orbital energy level diagrams for homonuclear diatomic molecules of the second row elements. So second row elements include many elements, but firstly we will uh, discuss first four. Okay, starting with lithium. The second row contains starts with lithium, then beryllium. So lithium and beryllium will discuss in this section, then followed by boron and carbon. Okay, so these four will discuss, and the rest of the molecules will discuss individually in separate sections. Okay, so starting with lithium. Now, first of all, what is the atomic number? That is 3. Then electronic configuration 1s2, 2s1, right? So single lithium atom contains 3 electrons. So if there are 2 lithium atoms that combine to form Li2 molecule, so how many electrons? So 3 plus 3, that is 6 electrons we have to accommodate in the molecular orbitals. So molecular orbital electronic configuration will be sigma 1s, sigma star 1s, sigma 2s and sigma star 2s. So if we now fill the electrons, so 6 electrons, one molecular orbital containing 2 electron each with opposite spins. So starting with sigma 1s, so sigma 1s2, sigma star 1s2, then sigma 2s2. Sigma star will not contain any electron because 2, 2 and 2, 6 electrons are completed now. Okay, now from here onwards, from the second row onwards, we observe one more thing, one more important thing, that is the inner molecular orbitals, they are not considered. So these are not considered because they are innermost and they do not take part in bond formation, so they are left untouched or undisturbed. And instead of this we write KK. This alphabet KK is used, and this signifies the K shell. The K shell, that is the inner shell. So we write the configuration as KK sigma 2s2, like this. So this is the molecular orbital electronic configuration. So from here onwards we'll use this KK for sigma 1s and sigma star 1s, the innermost orbitals. Okay, now if we want to calculate the bond order, so from this molecular orbital electronic configuration only we can calculate the bond order. So number of electrons in the bonding molecular orbitals. So how many electrons? So this is the bonding molecular sigma 2s. So while counting the electrons also for bond order calculation, we do not use the innermost. So only we will use this one. So only one bonding molecular orbital, that is sigma 2s, containing 2 electrons, and there are no electrons, 0 in the anti-bonding molecular orbital, divided by 2, that is 1. So lithium is singly bonded, that is single covalent bond. So Li2 molecule exists as Li single bond Li, like this. Okay, now quickly we can draw the energy level diagram also. So it's easy for this because this it contains so we are discussing only the outermost orbitals. So 2s in case of lithium, so 2 lithium atoms, so 2s and 2s, right? And these 2s atomic orbitals, they give rise to molecular orbitals. So 2 molecular orbitals, one higher in energy, another lower in energy. So which of this so this one, sigma 2s, sigma star 2s. Okay, so 2s atomic orbital contains 1 electron each. So 1 electron for each lithium atom, so total 2 electrons. So we have to accommodate these 2 electrons in the molecular orbital. So sigma 2s contains both the electrons. So from here you can see the same configuration we are drawing, sigma 2s2. So sigma 2s contains 2 electrons. So like this we have filled the 2 electrons. Okay, so this is about lithium. I hope it's quite easy for you. So then after that, then we'll quickly move on. After lithium, we quickly move on to beryllium. So beryllium, just one extra electron, atomic number 4. So say 1s2 and 2s2. So electronic configuration, so single beryllium atom contains 4. So 2 beryllium atoms, the diatomic molecule will contain 4 plus 4 is equal to 8 electrons. And therefore the molecular orbital electronic configuration will be, so we fill it like this, 2 plus 2 4, 2 6 and 2 8. So it is similar to lithium, just extra electron in the anti-bonding 2s orbital. So this we designate as KK, and the electronic configuration becomes KK sigma 2s2 and sigma star 2s2. Okay, so now we can easily draw the energy level diagram for beryllium. So similar, it is quite similar to lithium molecule. Okay, so 2s is the atomic orbital that participates in bonding, and from 2s we get 2 molecular orbitals, sigma 2s and sigma star 2s. So each atomic orbital contains how many? 2 electrons. So 2 electrons for 2 lithium atoms. So total 4 electrons for 2 lithium atoms. And then these 4 electrons we accommodate in the molecular orbital as sigma 2s2 and sigma star 2s2. Okay, fine. So this is our energy level diagram. Now calculating the bond order. So bond order we can calculate. So how many electrons in the bonding molecular orbital? There are 2. So this is our bonding molecular orbital, and sigma star is the anti-bonding. So 2 in anti-bonding divided by 2, so it comes 0. So that is why this Be2 molecule does not exist. So this does not exist. Okay. So just one point you have to note from here onwards, that these this KK electrons are not counted while calculating the bond order. So we have calculated this 2 electrons in the bonding molecular orbital sigma 2s and 2 electrons in the anti-bonding molecular orbital sigma star 2s. So this is how we are calculating and constructing the molecular orbital diagrams for lithium and beryllium molecule, and hope it's clear to you. It's quite easy, and hope this helps. Thank you.